Howdy folks, in this video we'll be taking a look at how to build a full stack application using Lambda, API Gateway, and DynamoDB. You've probably heard of examples of full stack applications like the mean stack or the lamp stack. Essentially what a full stack application is you'll have a front end, this front end being PHP for lamp stack or Angular for a mean stack, and it will communicate with a backend or database. For lamp stack, that would be MySQL, and then for the mean stack, it would be MongoDB. And the reason why you would want to do that is, let's say we had this React application right here, and we could add a list of to-dos. If I were to refresh the page, you can see that we lost our state. We lost our list of to-dos. And so if we were to store this in an external database and then load it as the component mounts, well, then our data could persist. And so all the major applications like Instagram, Facebook, and Twitter, they're all full stack applications in that they rely on their databases to pass the data on to their front ends. And so that's enough of that. We'll get right into coding. So to start off, we will create our DynamoDB table. And to do that, we'll run AWS DynamoDB create table. The table name we'll use will be a to-do list. For attribute definitions, we will use an ID, and that will be of type string, and we will also use a task, and that will also be of type string. For the key schema, we will use our ID as our hash, and then we will use our task as a range. Recall how hash means that it's a partition key. Not MongoDB, in DynamoDB, the tables are split off into partitions, and then within every one of these partitions, it will be sorted by the task. And then for provisioned throughput, we will have a read capacity unit of 5, which essentially means that 5 times 4 kilobytes is how quickly it can read. And then we'll do the same thing for write. Again, this isn't that big of an application, so 5 times 4 kilobytes will be good enough. And I have a typo somewhere. Attribute name. Oh, I see it. This should be attribute type. Read capacity units. Need a mess there. Alright, There you go. So now we've created our DynamoDB table. So now what we're going to do is we're going to create the role that will be used by our AWS Lambda function. And so we will create a file called entity trusted entity.json. And for this, I'm not going to bother writing it. I'm just going to copy it. So it's important to note because this confused me at first. So when you go to create your role, you are essentially telling AWS what service will be given access. And then it's only after you attach the policy that you say what this service can do. So here we're creating a role, and this role is for the Lambda service. And so all the policies we attach will tell what the Lambda server is allowed to do. And so to create our role, call it the Lambda role, and then we will pass it our file trusted entity.json. So now we'll create the policy. And again, I will copy it. So here we're saying that our Lambda function, our Lambda service, is allowed to put items into our DynamoDB tables, as well as scan the table for items. We're going to have to change this ARN to match our table. I believe that it's already set correctly for me, but for you, you can grab it from right here. So table ARN. And yeah, it looks to be the same. So we will just ignore that. To attach the policy, we use AWS IAM put role policy. And then the role name will be the Lambda role. The policy name will be DynamoDB access. Did I forget? Oh, whoops. Sorry about that. And then the policy document will pass in our policy.json. Alright, so now we've attached the policy. So now what we're going to do is we're going to create our Lambda functions. And for this example, we'll be using a Node backend. And so we'll want to start off by requiring the AWS SDK. Then we want to import the DynamoDB client. And this will allow us to run functions against our table. And then we will export our handler. Our handler will be called get.allTasks. And with a NodeJS backend, our function takes in an event, a context, and a callback. We will specify parameters, and the table name we're going to use a environment variable. Oh, should not have done that. table name like so. Alright, so now we are going to run the scan function on our table, and we're going to pass it the table name. If we get an error, we're going to want to handle that. But otherwise, we'll want to return the data. All right. Remember how whenever we create a Lambda function, we're going to have to zip up our file, and so zip it up like this. All right, so now let me just make sure I grab the ARN for our role right here, because we're going to need it. Keep that there just in case. All right, so to create our Lambda function, we'll run AWS Lambda create function. And we will pass in the function name, which will be get tasks. The zip file will be function.zip. The runtime environment will be NodeJS 8.10. The role, we'll give it our ARN. The handler, again, the syntax for the handler is the name of the function, which is get, and then the name of our handler, which was get all tasks. And finally, we're going to pass in our table name as an environment variable. So environment variables equals table name is going to be to-do list. I must have misspelled runtime. I did. Let's change that. All right, there you go. So now we'll do the same thing, but for our post function. And so we will create a file called post.js. Same thing, we are going to start off by importing the SDK. Then we're going to want to import a function that will allow us to create a unique identifier, or a UUID. And then lastly, we will want to import the document.client that will allow us to run functions against our DynamoDB table. So the handler will be called add task. Again, we need an event, a context, and a callback. The parameters here, we will pass in an item, and this item will have a ID, and the ID we will create on the fly using our UUID library, and then it will also have a task, and the task is going to be what we pass in, event.task, and then also we are going to pass in the table name as a environment variable again. So to add items to our DynamoDB table, we will use the putItem method, or put, I should say. We'll pass in the parameters, and then same deal. Alright. So like the other one, we're going to have to zip up the file, so we will do zip function2.zip, and we will zip up post.js. So AWS, actually we could probably just go back here and change the zip file to function2.zip. Oh, I forgot I need to change that to add task. And we'll also change this to add task. We have to change the name. Alright, so there you go. Now we have our two Lambda functions. So now what we can do is we can start creating our API endpoint. And so to do that, we do AWS API Gateway, create REST API, and then the name, we're going to call this to-do list. Now you're going to want to copy this ID somewhere because we're going to need it a lot. So next we're going to want to get the ID to our root path, and to get that you run AWS API Gateway get resources REST API ID. We'll pass it in the ID. So this is going to be the ID for our root path. Again, we're going to need that, so copy it. So now to create another path, we are going to do AWS API Gateway create resource REST API ID. We will pass it our ID right here, and then the parent ID. So this is the ID of the path we want to attach something else to. We are going to give it that ID, and then the path part we're going to add is tasks, and we'll copy this because we're probably going to need that too. Alright, so now what we're going to want to do is we're going to want to add methods to this route. And to do that, we do AWS API Gateway put method REST API ID. We're going to have to give it this ID again. And then the resource ID is going to be the ID to our route. And then the HTTP method here is going to be get. And we are not going to use any authorization. Okay, so now we're going to do the same thing but for put. So AWS API Gateway put method REST API ID. We will pass it our ID right here. Oh, I forgot the slash. Resource ID, we are going to pass it the ID to our route. The HTTP method we're going to use this time is going to be post. And then the authorization type is going to be none. Alright, so now what we're going to want to do is we're going to want to add responses to these HTTP methods. To do that, we run AWS API Gateway, put method response, and again, REST API ID is going to be this one right here. The resource ID again is going to be the ID to our route. The HTTP method is going to be get, and then the status code is going to be 200. So rather than do that all again, I know it's going to be slightly blocked on your screen, but we're going to change this to post. And there you go. And so when the response is successful, it will return a 200 status code, which is important for when we go to make the request externally through our application or through a web browser. So now what we're going to want to do is we're going to want to link our HTTP methods to execute the Lambda functions. You can do this through the CLI, but it's not that clear. And so I'll go ahead and do it through the console here. And so get started. We will select our to-do list. Here in the HTTP methods, we can integrate it with a Lambda function. So this one, we will use get tasks, hit save, okay. So as it shows here, whenever we make the request, a get request to this route, it will execute our Lambda function and then return a 200 status code if it's correct. So we'll do the same thing with post. This time we will do add task, save, okay. Alright, so for this to work, we also need to add the responses to our integration. And so to do that, we'll run AWS API Gateway, put integration response. Again, we will pass it the REST API ID, which will be this one right here. The resource ID of our route. The HTTP method. The get. The status code will be 200. And then we also need to pass in the selection pattern, but we're just going to leave it blank. And rather than type all that again, I'm going to just switch the get to a post. Alright. Now the last thing we need to do is to enable cores. Otherwise, things like fetch from our React application won't work. And the easiest way to do that is to do it through the console, because it will make multiple API calls. So you click actions right here, you have the option to enable cores. So we'll go ahead and hit that. Yes. Alright, so now that we have cores enabled, we should be able to access the API from our app. So the next thing we're going to want to do is to deploy our API. And to do that, we run AWS API Gateway, create deployment. And again, we need to pass it the API ID. It's this one. And then we'll pass it the stage name. For example, we'll just call it API. Alright, so now we're ready to make requests to our API. The format for the URL is going to be your REST API dot the region dot Amazon AWS slash day slash pass. Anyways, I'll make it more clear. So you take your API ID. So we do curl x get HTTPS the ID dot execute API the region. I'm using US East 1 dot Amazon AWS .com slash API slash tasks. And you can see right here we get the response, which is an empty array because we have nothing in our table. But if we were to run curl x post, and then we will pass it in a task of eat, and then the same URL. Just copy that. Give me a second here. So I'm in the Lambda console here, and if you look at the message right here, Lambda can't find the file get.js. Make sure the format handler is file name.method. So when I created the second Lambda function, I forgot to change this. So we need to change this to post.addTask. And if we hit save, this may or may not work. Oh, there you go. So now if I run the maybe it was right. If I run the get method again, you can see that it's gone ahead and added the task. And so now we're ready to create our React application. So we will do create React app, and we will call this full stack. And I will probably pause the video just because I believe this will take a long time. So sorry about that. I will see you guys in a sec. And we're back. So if I were to open it up in Visual Studio Code, we're gonna want to change App.js, and so I will remove most of this. Let's remove all this stuff. Alright, so what we'll want to do first of all is create our constructor, and this constructor will create or initialize our state, and our state will have an array of tasks which will be empty in the beginning. Alright, so the next thing we're going to want to do is create our input, and we will give it a label of task. The input type will be text, and then we will also have a button which will be enter a task. And then we are going to render a list of to-dos, and yeah, so we'll want to add a method that will take the input and add it to our state. Handle change. Alright, so we need to make sure that we bind this like so. We will actually have another property and state called item. Alright, handle change, and for handle change we're going to do this dot set state, and the item will be e.target.value. Alright, and then we need a onSubmit function. This dot handle submit. Same deal, we're gonna have to bind the keyword this. E.prevent default. Right, and then this dot set state. We will change the item to blank, and then we will add so tasks, and then we will add our item like so. Alright, now what we're going to want to do is we're going to want to retrieve all the items in our table and then put them into the state. And so to do that, we're going to run fetch, and we will take the URL, which we have right here. Oh, whoa. Like so. And then we're going to use a promise. For fetches, you need to convert the response into JSON using the JSON method. And again, that might take a random amount of time, so we need another promise. And then within this promise, we are going to want to just take the task and not the ID, so we will use a map, and then we will return the item dot task like so, and then we're gonna add tasks to state. So this dot set state tasks is going to be tasks like so. Alright. And now we are going to want to change it so that when we hit submit, it's going to add a item to our database. And to do that, again, we're going to use fetch. I'm going to take the URL from up here. And then for post requests, we're going to want to use an object as the second argument, and then the method we're going to use is going to be post. The headers is going to be accept application / JSON, and then the content type is going to be again application / JSON, and then finally the body, we're going to use JSON.stringify, and we are going to pass it in our task. Okay, so that should work. Oh wait, I'm forgetting. So we will get our list of tasks from the state, and then we will create an array of list items. So const to-dos equals tasks.map value index li. We're going to use the index as the key, although that's not best practice, and then we'll use the value right here. Alright, so if I go back here and cd into full stack and then run npm run start, hopefully I don't have any errors, but I probably do. I just noticed one thing. I'm forgetting to reset it. So to reset it, you're going to do b.target.reset. Alright. We'll open up the console to see if we see any errors. Come on. My computer's being very slow today. Maybe if I close some applications here. Alright, it seems to have loaded, but I do not see anything. So I'm gonna debug this and then I'll be back. And we're back. So I don't know why it wasn't showing in the console, but right here it says that item is not defined. And so we forgot to get it from the state right here. If I do that and then reload the page. Alright, now you can see that we got our list of tasks from the database. If I were to add another task like sleep, and then if I refresh, you can see that we still have sleep. So it added it to the DynamoDB table, and when the component mounted, we retrieved it. And so the last thing I'm going to do is we're actually going to deploy this application using S3. And to do that, I'm going to have to run npm run build, and this is going to use create react app to build our application so that we can host it statically. And maybe while that's running, I'll go ahead and start running other commands. So we're going to want to create a S3 bucket. So AWS S3 make bucket S3 / full stack app.corymacro.com. Let's check up and see how it's doing. Alright, perfect. So I'll just wait to see when this finishes. And then we'll go ahead and copy the files over. Perfect. Alright. So we're just going to want to copy over the contents of the build directory. So AWS S3 copy recursive build, and then the S3 bucket. So S3 full stack app.corey.com. Alright, so now it's gone ahead and copied that. So the next thing I'm going to need is to make the bucket public. And to do that, we're going to want to create a file called policy.json. And then you're going to want to copy the following contents. That should be JSON. There we go. All right. And you'll want to make sure that the ARN matches the bucket. So this is actually wrong. This is from a different tutorial. So we're going to want to change this to full stack app. So now to apply this policy, we're going to want to run AWS S3 API put bucket policy. Bucket is going to be full stack app.corey.com. And then the policy is going to be the one specified in our policy.json. Invalid bucket name. I forgot that when we use the S3 API, you should just specify the name and not the S3 prefix. Must be valid JSON. The first must be. Okay, let's try that again. All right, there you go. So now our bucket is public. So now if we go to the console and go to S3, you can see it's public right here. So if we click on this, then go to properties, we can select static website hosting, use this bucket to host a website, index.html, save. Now if we click on the URL right here, we get our app. You can see that we have the list of to-dos here, and we can go ahead and add another one. So let's say work, enter task. You can see it gets added. If I refresh, it's still there. So thank you for watching. If you have any questions, let me know in the comments, and I'll try to make sure I put all the code up in GitHub so you guys have access to it. Cheers.